Hi, we are Group 8. Since the exponential growth of plastic manufacturing, microplastics became more and more abundant in the marine environment, causing more and more problems to the marine species such as the mussel.
Mussels are benthic filter feeders that attach themselves to a hard surface. As filter feeding species, bivalves not only filter their nutrients from the water, but unfortunately also the microplastics.
There is some research done about the effect of microplastics in the water column on bivalves, but this was mostly research on the long-term effect. We wanted to know if the presence of microplastics had an effect on the filtration capacity of the mussels in the short term. To research this, we have the research question: what is the effect of microplastics in the water column on the filtration capacity of mussels?
So the hypothesis. We think the microplastics in the water column will cause a lower filtration capacity of the mussels. Since there are microplastics in the water column, the mussels will also take in the small plastics, which most likely causes the filtration to slow down and be less effective.
Our experiment goes as follows. We have a control group, a group with a low concentration of microplastics and a group with a high concentration of microplastics. For the research setup, 12 buckets of 5 liters were each filled with 3 liters of filtered water seawater. After filling the buckets with water, there were tubes installed with air flowing out to stimulate oxygen levels in the water. After the setup was ready, there were 5 mussels added to every bucket. In every bucket, the weight of the 5 mussels together was between 55 and 57 grams. The mussels were collected by hand next to the Teso harbor at low tide in the morning. To keep the mussels satisfied, there was 2 milliliters of algae concentration added before the experiment was done the next day. During this day, the mussels had time to acclimatize. The 12 buckets were divided into 3 groups of 4 buckets. The first group was the control group. The other 2 groups had added microplastics to them. Starting with the control group, right before starting the experiment, 20 milliliters of algae solution was added to each bucket. Right after it was visible that the algae were completely mixed in, the first measurement was taken with a pipette from every bucket. The water from the 4 pipettes was added to 4 different cuvettes, and then the turbidity was measured with a spectrophotometer. The spectrophotometer measured the wavelength at 664 nanometers. These measurements were done every 10 minutes continuously for 60 minutes. In between the measurements, the cuvettes and pipettes were rinsed with demi water. After doing this experiment for the control group, the exact same was done for the second group. The only difference was the adding of 0.1 grams of microplastics with a size of 125 till 250 micrometer to the 4 buckets. For the third round, 0.5 grams of microplastics was added.
In order to gain clear results, 3 different graphs of each group of mussels with different microplastic concentrations were made. Per replicate, a trend line is inserted, as this will be used for further calculations regarding validity of our research. In the graphs, the decline of the particles in the 4 different buckets can be seen. In the right corner, the exact formula of each trend line is shown per bucket. The first number in each formula indicates the slope of each line. It can be seen that the starting turbidity values differ among each of the groups. In the control group, the values lie further apart, while in the 0.1 and the 0.5 gram group, the values are much more close together, except for one outlier in the 0.1 group.
From the data of the graphs, a single factor ANOVA was conducted. This is done with the slope of each trend line per replicate. This statistical test is done to compare the 3 different groups and see if at least one of the groups shows a statistical significant difference. A p-value of approximately 0.06 can be seen. This bar chart shows how turbidity decreases and the standard error under the different treatment conditions. It can be seen that the 0.5 gram group has a much smaller average decrease with a quite large error bar, indicating high variability in the results.
As shown in the results, a potential effect can be concluded despite the p-value, as the p-value is marginally significant. This indicates a potential effect of microplastics when in large concentrations on the filtration capacity of mussels. This can be supported by comparing the graphs of the 0.5 gram group and the control group, as a lower decline of turbidity can be observed. This potentially means a lower filtration capacity. This can also be seen in the bar chart.
Yeah, this was our experiment. We think the marginally significant result indicates that a high concentration of microplastics can lead to a lower filtration capacity of mussels. For further research, the following things could be taken into consideration. First, we did not rule out the possibility of dead mussels, which might affect the filtration capacity.
There were floating microplastics, which could lead to an improper distribution of the microplastics in the water. And next time we could also do baseline measurements before adding the microplastics. For next experiment, more different concentrations and replicas could lead to even more data. Thank you for listening.